I'm going to hit the highlights for how to use the built-in Desmos Calculator. I wanted to, as quickly as possible, give you the highlights, the stuff that can change your strategy and your score with very little practice and very little understanding of how the calculator works, just using its basic features. So hopefully this will make a big change in just a couple of minutes. Let me just talk quickly about what the Desmos Calculator even is. It is built in to the app that you will take the digital SAT on. So you do not even need to bring a calculator with you to the SAT anymore. Now, I still think you should. Something simple, something like a scientific calculator just like this one. It has basic functions. It does have some more advanced stuff, but I would only really use it to do some crazy multiplication or division or addition, like the more basic stuff. Let the Desmos calculator be where all the fun stuff happens. And that's because the Desmos calculator is a graphing calculator mostly, so we can see all these equations in real time. And the best part about it is it's free, and you can use it right now if you want by going to desmos.com/calculator. I definitely recommend that if you're planning to take the SAT, you use this calculator in your practice so you can get used to how it feels and what it does and where all the buttons are. It's definitely a little complicated at first, but with practice, it should be second nature how to work through some very complicated math and make it much, much easier. In this video, I'm going to show you 4 specific things, okay? I'm going to show you how quickly we can graph and solve systems of equations, how we can solve for x even if we don't have an equation per se, and I can show you how we visualize changes to equations and just graphs in general, and how we can use SAT strategies like guess and check even on this calculator. So it does really lend itself to the SAT in particular because it lets us play with some things and test out answers in ways that a normal graphing calculator might not be able to do. And that's the thing. I think that the Desmos calculator is better than any real life calculator, graphing calculator that I've ever seen. It just has fewer buttons, things are more intuitive, it's easier to use, so hopefully you feel the same way. Let's dive right into a first question here. This is pretty straightforward. System of equations, you got 2 equations here, and in math class in school, you would be asked to solve this system probably algebraically by either doing some sort of substitution or elimination, something where we would eventually end up with an x equals or a y equals. But I wouldn't bother with any of that here. Don't waste your time. The calculator at its best is just going to let you see where the point of intersections are. So you can see here, I've already taken the time to just enter the 2 equations, make sure that they're correct, that you don't accidentally enter the wrong numbers, but otherwise just enter them in. And if you look at the red line here, you can see that it's also automatically calculating your x and y intercepts. That's very convenient for other questions. But the blue line is off the screen, so we should scroll around until we find a point of intersection. And again, if you click it, you'll see it just pops up. It does the calculating for you, -9, -44. So what's happening here though is they're trying to get you into a trap with choice C, so we should zoom out, or we can hit the home button to go back to the origin and now find another point of intersection that actually gives us an answer choice. And if we zoom out, we can see there's the one that we had before, -9, -44, and now 14 is the correct answer because that is the x coordinate of the other point of intersection. So what do we have to do to solve this question? Basically just type some stuff into a calculator and scroll around, and boom, the calculator just gives you the answer. Of course, there are going to still be some trap answers. Maybe we misread a number, we confuse that 9 and -9 are different numbers, and so we pick C. Or sometimes what they'll do is they'll ask you to solve for x, but then they'll give the y coordinate of the point of intersection just to confuse you, so always double check those things. But otherwise, there's really no way to make some careless mistakes here. Whereas if I did solve this with algebra, it would be long, it would be tedious, and the chance of me just calculating something wrong, moving an x in the wrong place, it's very high, and so I could waste a lot of time just to get the wrong answer. This is so much better. Pretty much every system of equations, you're now going to want to enter into the calculator. Some of you who are really great at algebra might find some situations where it's better to do it by hand, to use your scrap paper and show the work. But with practice, you'll figure out those situations. And for some of you, if you don't have that sense of whether it's going to be easier to do by hand or easier to do in the calculator, then just always do it in the calculator. It doesn't matter. It's still going to be effective and efficient if you enter these things quickly. Let's look at a slightly weirder situation. Here's another equation, but this time it's just one equation. Notice there's no y coordinates, no y variables here. There are a couple of ways to handle this. Definitely though, if I were looking at it, I'd be like, I don't really want to solve this algebraically by hand because it's got square roots. It seems risky. And what we should do then is enter it as written into the calculator. So if you're having trouble with square roots, you can hit the button on the bottom, that little keyboard button, and it'll bring up all the functions. So you can hit that, and then you can type the rest. So 3x minus 10x equals, or you can also type the letters SQRT and it'll auto-generate the square root symbol for you. So this is why you should practice at home. Get used to that stuff. When we graph it, you'll see that we get these two vertical lines. And if we zoom out, they're just straight lines up and down the whole way. So there's nothing fancy. It's not a curve like the other ones before, but they happen at -5 and at 3. And basically, that's just giving us the answer. Either -5 or 3 would be valid answers to this question. You don't need to bubble both, right? Notice the question just says, what is one possible value? So just pick one, but both are acceptable. So let me just explain what's happening here. Because there's no y equals, this calculator is not graphing this like we would think of a regular line or a parabola or anything that kind of curves around. It doesn't have the kind of shape that a normal equation with a y and an x would have. But what the calculator is doing here is just solving the algebra for us. So it's ending in the same place that you would end if you did this by hand, right? You'd have x equals -5 and x equals 3 as your two answers. And you'd box them and you'd be like, yeah, I did it. So what that looks like though is a vertical line at -5 is the x equals -5 equation. And to draw x equals 3 on a graph, you would get a vertical line at x equals 3. So it's kind of just giving you the x values, but they're gonna look like these vertical lines. But that's okay, as long as you're comfortable with that, you've just let the computer do all the solving for you. That's awesome, that's what we want. The reason I would definitely do that here is the square roots. The square roots maybe are also causing a little bit of a problem that I notice sometimes with this strategy, which is we can't click the x-intercept and get the actual point like we could before when you were doing the intersections or the intercepts there. So I think that the reason that happens is the square root is just like a messy thing and the computer can't really give us that point, but it doesn't matter, right? We could zoom in, we can clearly see that the lines go through -5 and 3. I guess it's possible that instead of going through 3, it goes through like 2.9999999 forever. But like the odds of that happening are very slim, and we can of course keep zooming in and really just make sure that the vertical line is where it looks to us. And that saves us a huge amount of time and headache and chance of a mistake by actually being able to just let the machine, the calculator, do the calculating for us. So not only is it a graph, but it also is an algebra solver. This is really helpful. And just like before, there might be cases, there probably will be cases in fact, where letting the calculator do the algebra is a waste of time. The algebra is so easy or something that it's just better to just do it yourself. But again, if you are not good at determining those situations, then you're probably just not good at algebra. And so you probably do want to default to the calculator as much as possible to just do as much of the work as possible for you, because you cannot be trusted to do it yourself without errors. But this is why you practice tests the same way you would take the test. Have the calculator ready to go and know when, try to figure out when you should go to it and when you should do things with a pencil and paper, your scrap. Let's take a look at another one. Here we have a question that would definitely throw people off. It's giving us an f of x equation that's kind of complicated. It's also then telling us to change that equation in some way by talking about a new equation, g of x, that has this f of x minus 4 piece. And then we have to find the minimum value of both of these, or I guess of the g of x equation. So what would throw people off here is they don't understand like intuitively how the graph is going to move. Some of you might, but I do find that this is also one of those cases where people are prone to error. So I wouldn't trust just my logic and my knowledge. I'd want the calculator to show me that my instincts are correct. So what we can do is not only use y equals to set up an equation, but we can use function notation itself. So we have f of x here setting us up so that way we can type the original f of x equation. And then the second line, I typed the g of x equation using f of x. And so it's literally just the two things that they gave us in the question. I just typed them as is. And let's see, it's going to show us what happens as we change this. So you can see, oh, here, yes, the letters are all given. So if you don't have a keyboard for some reason, you can always find the letters in the keyboard thing. And we get a parabola, and there's our vertex, negative 12, 4, and you can see there's a trap because that's the original minimum. But if we turn on the g of x, we see that it shifts to negative 8, which is the correct answer, and we can turn off the one we don't want so we're not confused. And that's really it, is we're able to see this graph move in a direction rather than have to actually just guess at what the direction is going to be or think about it. We can see it and know for sure. There are definitely ways to do this manually, to find the vertex of a parabola manually, to shift a graph manually. But why do it? Why even open the door to a possible careless mistake? Just let the computer solve it for you. Let the calculator, Desmos, do the work. And that's really the whole point of this, is that you have to recognize the SAT is very good at creating situations where you're going to make a mistake. It's good at forcing errors. So knowing that, we have to be humble and doubt ourselves and be able to just know when to put it into the calculator instead and let that thing do the work. Let's look at one more situation where I think it would be difficult with any other graphing calculator to solve in a good way. So here's a question where we don't have an equation, actually. We have an expression, so there's no equal sign. But you can see I set up the first equation, the first expression, as an equation by just throwing in a y equals. And basically what that lets me do is see this thing more like the kinds of graphs I'm used to, right? Where it kind of moves along the x-axis and goes up and goes down and all that stuff. So I'll zoom in a second, but you can see it's got a little bump at the origin. Now they're asking us to figure out what an equivalent expression would be. We can definitely just take this second equation and type it into the second line. And again, I'm going to use a y equals to do that. And we can see the keyboard will let us do all of this if we don't want to type or we don't have a keyboard. So y equals, and I'm going to type the 3, and then obviously create a fraction is just division. So just use the division symbol, and then x squared plus k. And you'll see when I hit the k, it's in the letters, that we get this option to add a slider. So we're going to click that, and we can see a new line comes up. And it literally is a slider. And if you slide it, you see all the different versions of this equation as if k is different numbers. But we don't want it to be random numbers. Let's try the numbers that are in the choices. So we do 7, and we zoom in. We can see these two expressions are very similar, but look, they're not quite the same. There's just a little difference. So if we change it to 8, though, we can see now the two green and black lines overlap, and we can turn them on and off and see that it's literally the same thing. If we try the other choices, we can see, again, 21, they're different. 392, it's going to be different. And so we know now that 8 is the answer because we were told to find an equivalent expression. And by playing with this value of k, with the different guess and check answer choices that we have, we can see which one gives us the graph that's the same. So normally, old SAT, no calculator, we would have to do this by hand and think about this conceptually and algebraically and understand why the equations are actually the same. But with the graphing calculator, we can just see what's going on much more easily. We can test these different numbers out, even if we don't know it for sure. The slider lets us plug things in. We can either use the slider that's there, or you saw me typing the specific numbers that I wanted. And as I change them, the graph of the equation changed as well. And we can just wait until we get the equation that we want because the graph will be what we want it to be. And so these equivalent expressions should produce equivalent graphs. And they only did it 8. I could see it. There was no doubt in my mind. In fact, I still don't really know why that's the case. I don't care. I have the answer. And so very quickly, within just a few seconds, this very hard question becomes much easier and you can get it confidently. And there will be plenty of questions where you can't use the calculator this way. But now you have more time to do the hand and scrap paper kind of stuff that you need for those other situations. It's really, the calculator is a great tool. It is not going to solve every single question on the SAT, but if you can use it more often to claw back some time, then for the truly difficult stuff, you will be able to hopefully finish just by doing it by hand. Let's review what we talked about here. Again, the calculator is built into the section. You don't need to bring a calculator, but you can if you want, just to have a backup, but you should get comfortable with the Desmos calculator as you practice. Get used to where the buttons are, get used to how to type things, get used to all the little shortcuts. And like I said, there are other tutors out there with videos that are much longer that are going to go into much more detail about what this calculator can do. There are some other features. I'm skeptical of some of them as being more efficient, but maybe for you, you'll like them. So go into the other tutors and check out what they're doing. But for me, the key pieces are what we talked about. It lets us graph systems of equations very easily. It lets us solve for X for very difficult algebra very easily. And we can use this slider to play around. Even if we don't have a specific value, we have to find a value, we can guess and check our way to it. And the third bullet point there is, I think, the most important one. In all of these cases, the thing that a graphing calculator lets us do is visualize algebra. What so many people struggle with in algebra is it's all kind of conceptual and abstract, right? What is this X? It's a number, but it's not a number. It's a number we don't know. And so it's difficult to wrap your brain around what's even happening. But with this graphing calculator, we can see what an equation looks like. It creates a shape, right? We can compare shapes. We can see shapes change and move and where the shapes cross. These are all really powerful things that I think tap into the way the human brain really works. So we're going to use the calculator to just think the way our brain wants us to think. It's just a really great addition to the test. I think it's going to make some of the math way easier for a lot of you. So we want to be able to take advantage of it.